Hi everyone, my name is Amisha Lalwani and I'll be sharing a report. This report documents the setup, configuration, testing of 5G core network using Open5GS, which is an open source 5G core implementation, and UERANSIM, which is user equipment and RAN simulator. The goal is to simulate a functional 5G environment where a user equipment can communicate with a G-Node B, which is nothing but a 5G base station. I'll be using a virtual machine. This is VMware Workstation Pro with Ubuntu 22.04 LTS Jellyfish version. Here you can see this is Ubuntu 22.04 LTS Jellyfish version. You can download this desktop image and create a virtual machine using VMware Workstation Pro. So moving forward, we can start. Uh, I'll be needing my report. Yeah. Okay, the first step is to update the already installed packages. After this, we'll be adding MongoDB. I'll be following the official documentation of MongoDB for that part. It's available on this website. I'll share the link. Okay, so first step is to install GNUPG. Then we need to import the GPG key. MongoDB is needed to manage the subscriber information. When we create multiple UEs using Open5GS, they are known as subscribers. We need to MongoDB to maintain its information. Yes, I have already installed MongoDB. That's why it's asking whether to overwrite or not. Then we'll update our packages again. After this updation, we'll take the latest release of MongoDB. First, it needs to, update successfully. Yes. Now with the latest version of MongoDB. Okay, then we need to see whether it is, first we need to start. Hopefully we'll not get any errors. Yes. Then we need to see whether it's active or not. So we can see MongoDB is active and running. Next, we need to install Node.js. Node.js is needed for the backend of web UI. Okay. I'll be using this command. You can get this from the official documentation of Node.js. So Node.js is now installed. Now we'll get the latest version of Open5GS. PT repository. PPA Open5GS latest. Will take some time. Press enter. So Open5GS is installed. Now we need to get software properties. Then sudo apt get -y update. Okay, then sudo apt install Open5GS. Here the error was because I had not written sudo. We need to do this with the root privileges. So we need to see the status of Open5GS. For that, we'll write sudo. So need to see the status of the services. So we'll type sudo service Open5GS all services status. Of course, password. So we can see NSSF daemon is active and running. NRF daemon is also active and running. Next we need to install the NetTools and see whether OG stun interface is up or not. OG-stun is tunneling interface which is used to transmit packets between UE and GNodeB. So we'll install the NetTools apt get install NetTools password. Okay. So now using ifconfig command, we can see whether OGSTN interface is up or not. Here is our OGSTN interface. It's up and running. Yes, running. Okay. Next, moving forward, OGSTN here, maybe because I am running for the second time, it is not showing the IPv6 and IPv4 packets. Oh, sorry, addresses. It is interface which is related to Open5GS. It is tunnel interface which is used for user plane traffic in Open5GS. It routes packets between user equipment and mobile core. It typically uses this subnet for private networking between core and components, and it supports both IPv4 and v6. It acts as a virtual interface managing data sessions for connected UEs. In my output currently I am not able to see both. Maybe because I am running for a second or third time. In the first time you should see this. Then we'll install last web UI. So to install web UI, I'll be using this command which is available in my report. Then I'll enter my password. Here's this command I'll use called -clhtpbs. It will take some time to install web UI. After successful installation, you will get a username and password which will be used to log in to the home page. I'll show you how. It is a time-taking process. I'll pause the recording and I'll show you when it's installed. Okay, so now continuing after web UI is installed. Let me- So here we can see the password and username. I hope it's visible. I'll just, it will take some time to become responsive. Yes. Now I'll move up so that you can see. Here you can see the username and password is visible. The username is admin and password is 1423. Now where do we need to enter this password? So you will need a port number. We'll access it on localhost here. So you need to enter sudo systemctl status Open5GS web UI. Here we can see it is running on localhost port 9999. So we can open link. Be slow. Yes, I'll wait. This happens when you use virtual machine. It will take some time to become responsive. Yes. Now I don't need to log in again because I am already logged in, but you will basically see a login page where you have to enter the username and password which you have been provided on the screen. Then you will enter this page. Okay, now moving forward. Okay. So this was basically the section 1 of our report. Section 1, which was installing and setting up Open5GS. Now Open5GS is installed and it is ready. Now moving on to section 2 of our report. Okay, section 2 is setting up UERANSIM. Okay. Now again in a brand new terminal. We need GCC and these tools to compile UERANSIM. These tools are needed to compile UERANSIM. I'll just type in the command install make GCC G++ lab SCTP dev lk SCTP tools IP2. Oh, I made a typing error. G++. And we can write git to install that also. Now you need to add CMake, which will use snap. Sudo snap install CMake classic. It is already installed on mine. So you need to make directory ueransim and move into that directory. Okay. So You need to now clone this UERANSIM repository. Okay. After cloning, we need to make, first we'll need to move in UERANSIM, the one we copied, cloned. Okay, now we'll make. Hmm. So it started to make the folders. It will take some time. It will show the entire logs. It's also a time taking process. After making, we just have to test our setup, and then we can move to section 3, which is major part of this project. So I'll be pausing the video and I'll return once this make command has run successfully. So I'll be recording after make of UERANSIM. Make command of UERANSIM is completed. I'll open the virtual machine again. So here we can see UERANSIM is successfully built. Now next part. You can see the logs over here. All these logs you can see. Then after UERANSIM is successfully built, the next step is to test our setup. For testing our setup, we can go to a fresh terminal, and then we need to list all the files inside UERANSIM folder. We need to go inside the config folder, and then we can see all the files in config folder, and then we can try and build the gnodeb file. -c open5gs.yaml. Oh, I made a typing mistake. Open5gs.yaml, gnodeb.yaml. We need to build Open5GS gnodeb.yaml. Now we can see that ng setup is successful. Trying to establish SCTP connection. SCTP connection established and sending ng setup request. Ng setup response received and procedure is successful. Now we can move to third part, which is the most important part of our project, which is configuring SCTP and NGAP with UERANSIM and Open5GS. We know that SCTP is Stream Control Transmission Protocol, which is a transport layer protocol like TCP and UDP. It is used in telecommunication networks, especially for signaling messages in 4G, LTE, and 5G networks. And NGAP is a control plane protocol that operates over SCTP. It is responsible for communication between 5G G-Node B and AMF in 5G core network. NGAP means Next Generation Application Protocol. So first we need to see that AMFD service is active and running. Can go to a fresh terminal, and outside all these UERANSIM folders, we need to go to desktop, cd desk, because all that folders are on desktop. Oh, I made the typing errors. Cd desktop. Now we can check whether AMFD service is running or not. Sudo service Open5GS AMFD status. Class का password, and it is active and running since Wednesday, 1 day 2 hours ago. Okay, so now we can check the contents of 5GS directory. Stop this, and then we can go to cd etc. Open5GS, and you can see all these files, AMF, AUSF, all the 5G network functions file are present here. You can list all and see details about these files also. Now these contains YAML configurations for various 5G network core function 5G core network functions such as UPF, user plane function, AMF accessibility and mobility function, SMF is session management function, PCF is policy control function, NSSF is network slice selection function, HSS is home subscriber server, and other serving gateway control and user plane. TLS and HNet directories store security certificates and networking configurations. Then we can also get IP addresses of these functions by simple command grep -i add or star.yaml. Here we can see the part which is not commented out is the IP address. We can see the IP address of amf.yaml is 127.0.0.5. Then we have IP address of ausf.yaml, bsf.yaml, and mme.yaml. All these IP addresses you can see by using this command. Then moving on, we have we can check the contents of amf.yaml. amf.yaml will contain first logger configuration, which will store the logging information, log files. All logs related to AMF are stored in this folder path, which will be returned in this logger configuration. Then global settings will store the maximum number of UE that can be increased on memory size. Then AMF configuration will store service based interface IP address, which is the local host, and port, which will be used for communication with other 5G core components. Then client configuration, which is commented out, consists of NRF and SCP. NRF is network repository function, which holds the register for all network functions, and SCP is service communication proxy. These are commented out, meaning AMF is not currently registering itself with an AMF or SCP. Then NGAP which is used to handle signaling between Gnode B and AMF. Its IP address is in the NGAP part of the amf.yaml. Then metric server stores the address of server which is used for monitoring. Guami, which is a 5G identifier, holds the globally unique AMF identifier. PLMN ID stores the public LAN mobile network ID, which contains the mobile country code and mobile network code. All these are identifiers, 5G identifier. Then TAI will hold the tracking area identifier and supported PLMN. Okay, so summary for this is that AMF handles mobility and management and NAS signaling for 5G core network, and it listens on local host 47777 and interacts with NGAP and matrix surfaces. So here is the entire file. You can see in this also. In the you just have to type more amf.yaml. and you can see everything in this file. Okay, so now moving on, we'll need to create a separate gnode b and user interface user equipment to test whether they are communicate whether this 5G core is setup is successful or not. So first, so we need to go outside these folders, move back to our UERANSIM, cd desktop, UERANSIM, UERANSIM. Then we can see all the files here. Then we will move to config. Here we can see the gnode b and UE files are present. Open5GS gnode b.yaml and Open5GS UE.yaml. We need to copy these files and create our own gnode b and UE. So we'll just copy them. Open5GS gnode b.yaml. You can name it anything. I am naming it gnode b2.yaml and Open5GS UE.yaml, copy into UE2.yaml. Okay, so now we can view all the files, and here our gnode b and UE2 files are created. So after creating our separate gnode b and UE files, we need to now make few changes to our gnode b and UE files. So I'll just open gedit gnode b2.yaml, and I'll also open the other file. Not responsible. Okay. And I'll also, it is already open, but you can use gedit command. Here we have to make changes to the local IP, link IP, NGAP IP, and GTP IP. You can make it anything within the range of valid IP addresses. I have changed the link IP to 201 and NGAP IP to 200 and GTP IP to 100. Also, we can see the mobile country code and mobile network code, and number of slices is equal to 1. And in UE, we don't have to change anything for now, but you can see here the SUPI is given. This SUPI will be used when we'll create the subscriber. Also, gnode b search list, we need to edit this when we'll create our UE in the next part. Okay, so moving on, we have saved our changes to gnode b2.yaml, which is our custom gnode b. Next step is we need to open Wireshark so that we can see how the packets transfer takes place. Okay, so Wireshark is open, so we need to select the loopback interface here. Okay, and we need to apply the filter IP address is equal to 127.0.0.5, and we can see the heartbeat packets. This means there is already an SCTP connection, but we can also check the logs by running the build command. We can build our custom gnode b and see the logs. Build nr mid typing mistake, build nr gnode b minus c gnode b2.yaml. So trying to establish SCTP connection, then SCTP connection is established, then SCTP association is set up, then sending NGAP request, NGAP response received, NGAP procedure is successful. All this is taking place on this IP address and this port number. Here also you will see this. Okay, see the SCTP handshake begins with the init packet, then init acknowledgement is received, then cookie echo cookie acknowledgement, then NGAP setup request, then NGAP setup response, and then heartbeat messages tell us that the connection is alive. Okay, So this shows that our Gnode B is now successfully connected to 5G core AMF, and SCTP and NGAP handshake is working correctly. The Gnode B is now ready to serve UEs and like 5G smartphones or simulated UEs in UERANSIM. You can check the AMFD status again. So I'll just check it again to see whether it's added or not. We'll remain in the same folder and just type sudo service Open5GS AMFD status. So it is active and running, and number of Gnode Bs, the number of Gnode B is now 3. The 2 I added earlier, and now Gnode B N2 is also accepted. So I have total of 3 Gnode Bs. If you are doing this for first time, it will become 1. Okay. So we can close all this previously done, and we can start the UE setup part from fresh. We don't need all this. I mean we need the connection, but we don't need all these terminals. Okay. So I'll just open a fresh terminal and close this old terminal. Now moving on to last part of our practical, which is connecting our custom UE to Gnode B. So for this part, since we know that these are all virtual and no actual packet transmissions takes place, therefore we need this add-on, which is Wireshark dissector for radio link simulation, and we'll have it from this GitHub repository. I'll just quickly move to our folder, UERANSIM folder. Now we can see we have only UERANSIM in our folder, but we need this tool also. So I'll just use git clone https github.com Louis Royer, spelling mistake, Louis Royer RLC RLS Wireshark dissector, Wireshark dissector dot git. Okay, so now we can see it is cloned, and just to confirm, we'll check. Yes, it is there. Then you can skip this part because mostly it is the same, but you can check this. To check this, you will just need to go to Wireshark. Mostly it is same, the path in everyone's will be same. Then you will go to about Wireshark plugins, and here xtap syscodum. This is the path, your user library x8664 Linux GNU Wireshark. Okay, so I'll just move to my terminal, and first we need to activate our plugin. That I'll move to this cd usr library x8664 Linux GNU Wireshark. Okay, maybe I made again a typo. User. So no, first I'll need to come out of this UERANSIM. No, no, I need to do this in UERANSIM only. I made some typo. USR library x86 Linux GNU Wireshark. No, maybe I'm to come out of this. Search directory. Why is it should work? Let me try again. I'm in my UERANSIM folder. User library x86 64 Linux GNU Wireshark. Yes, so maybe there was some typo. CD I had not done this. This part is missing. Library, rest is same. Maybe because of that there was this error. Then we can list what we have here, and we can see we have plugins and next step. Then we'll move to plugins. Just add plugins over here, and what we have in plugins, we have 3.6, 4.4 and RLS Wireshark dissector. We need to activate this. In my, it is already activated, therefore it is coming, but in some people it won't show RLS Wireshark dissector unless you activate it by using this command. Then only it will show. Let me do that. Sudo cp. It is basically we are copying this dissector in our file ueransim rls wireshark dissector. It won't show after till we do this step. After this step only it will show in your directory. Wireshark. Okay. Ask for your password. Okay. Now if you do ls -lrt, you can see ILS Wireshark and Wireshark dissector. Oh, I copied this into Wireshark. You have to do in dissector. I can do it again. And again LSLRT. See, you have two different. This I had done yesterday, and this I have done today with you. 13th March. Yes, today is 13th March. Okay, then we need to add our subscribers to the home page we had logged in into part 1, and we have to use this SUPI from UE1 UE2.yaml. So I'll just show that part. How will you do? First you come here and you will have to add a subscriber. Press this button here, and in here in IMSI you need to open the UE2.yaml file. Score sorry there and gedit. Need to put out of this because UE file is not here. You need to go to desktop. Then in UERANSIM config. Yes, here is our UE2.yaml and we need to open it. Gedit UE2.yaml, and so here you can see the SUPI is given. It will be same, like you don't have to change it, you just have to copy it and you have to paste it over here. And then you have the subscriber key, authentication management fee, operator key, USIM ID. You don't have to change anything, just you have to click save. I cannot save because it's same to my previous UE, it's duplicated. You will have to save, then you can continue. Maybe I can change this ID. I'll do it too, and I'll just save it. And now I'll copy this, and then I'll add a subscriber. This subscriber configuration, to store this information about a subscriber, we installed MongoDB. Then I'll just click save, and here a new subscriber is created. Okay, so in this GNodeB search list, we have to add our this is nothing. We need to add our GNodeB, like the one we created, gedit gnodeb2.yaml. It's also open. See, here we have the NGAP ID, link IP. So my report also I have mentioned, we need to change our UE's GNodeB search list to our GNodeB's link IP, so that the UE can search for our GNodeB. It should know now that there is a GNodeB for me. So we'll just copy this from our GNodeB, the link IP, and I'll just paste it here in the search IP. Then I'll just click save, and all the changes we need to make are done. I have updated the search list and I have added a subscriber. Then we have to make sure that our GNodeB is running. Here, in my previous practical, I had created GNodeB1.yaml, but here I am using GNodeB2.yaml, so I have to make sure that it's running, because if it's not running, then there will be no connection. So I'll just move into a fresh terminal, and I'll go to, no, I was in the right, so I'll go to config again and just build my GNodeB file, so that it's up and running. nr GNodeB -c GNodeB2 dot yaml. So it's up now, the main part, which is building our UE. But first I think we need to turn on our Wireshark. I'll just remove this old Wireshark so that there's no confusion. Okay, so Wireshark is up and running, and I'll just select interface, any interface. Yes. Okay, so I'll apply the filter of RRC connection. This was actually established previously. I don't need this, but let's keep it. Now I'll just build my user equipment file. All the things are done. Just So there are two things in building user equipment file, that you can either build it without root privileges or with root privileges. In without user privileges, you will get an authentication error, and also the tunneling interface will not get set up. So I'll first show you without root privileges. I'll just build it. Build nrue -c UE2.yaml. So here the tunneling interface didn't set up. Also there is an authentication error over here somewhere. I'll show you. Yes, sending authentication failed. PDU session established but authentication failure. See, there also authentication request, authentication failure. Since authentication failed, security mode command activated. Then this MIB, SIB uplink and downlink transfer. You can just stop this and we can restart our Wireshark. No need to save this. Quit without saving. Yes. Now I'll just start my Wireshark again. So Wireshark is up. I need to select any interface. There is any. Yes. Okay. So I'll just apply nrRRC. Nothing is there. Now I'll just do that build with root privileges. I'll just write it again. Build nr ue. It's hard to remember the comments. Sometimes I get confused in remembering all these commands. ue.yaml. Then I'll need my password since it's with root privileges. Think I entered incorrectly. Yes. See, with root privileges, everything goes smoothly. So UE switches to deregistered initial UE states. Here are all the logs you can see. Connection setup for PDU is successful. Also, the tunneling interface is up. Now in Wireshark, you can see that yes, RRC setup request, then RRC setup, then RRC setup complete, then authentication request, authentication response, no failure. Since we had done this with root privileges, then this is the uplink and downlink message transfer. So this practical is now completed. You can go through this report. I'll be sharing this report and all the necessary links. So okay, thank you for watching.